Hello, ladies and gentlemen. Let's take a look at chapter 7.6. We're going to solve exponential and logarithmic equations. Now, there are different varieties or different methods at solving these, and it's going to be really important to be able to recognize each equation and what the process is to solve it. So we're going to do first is we're going to start by solving by equating exponents. So we're going to start off with a real simple example here. So let's say we have base 5 to the 2x, and it equals base 5 to the x minus 2. Now, you'll notice the bases are the same. If the bases are the same, we can simply set the exponents equal to each other and solve for x. All right, and in this case, x equals -2. Now, just to check it, I'm going to go ahead and plug that back in. So if I plug that back into x, okay, 2 times the -2 is -4, so that's 5 to the -4 power. And -2 minus 2 would also be a -4. Okay, and they are definitely equal to each other. So -2 is the correct answer. Now, that's when the bases are already the same. But what if they are different, like in this problem? Let's say we have 8 to the x plus 1 equals 2 to the x minus 9. Now, since the exponent has two terms in it, I'm going to go ahead and put parentheses around those because it might help out later on. All right, so we have different bases in this case. We've got a 2 and we've got an 8. Well, what we want to do is we want to break that 8 down so that it is a base of 2. So 2 to what power equals 8? Okay, and you should know that from all of the math we've been doing. Okay, you already know that 2 to the 3rd power is 8. So what we want to do is replace the 8 with 2 to the 3rd power. So here we go. So we're going to replace that 8 with 2 to the 3rd power, and then we still have the x plus 1 equals 2 to the x minus 9. All right, now that they are the same, we can just set the exponents equal to each other. So 3 times x plus 1 equals x minus 9. All right, now it's an algebraic equation. We're going to solve it. All right, and we find out that x equals -6. And if we plugged that back in, just to show you here, I'm going to plug that -6 in for x. Okay, and I'll show this with the calculator. So if I go here, okay, and I put 8 to the -6 plus 1, you will see that gives me that ugly looking number. Okay, but then if I take 2 to the -6 minus the 9, I get the exact same answer. Okay, so -6 is what we ended up with. All right, let's do another one. Okay, this one's going to be slightly different. In this problem, we've got 9 to the 2x equals 27 to the x minus 1. Now, is there any way that I could change the 9 to get 27 or 27 to get the 9? Is there any exponent that I could use for 9 or the 27 to convert from one to the other? Okay, well, no, there's not. Okay, 9 to some power, you're not going to get 27. Okay, because we know 9 to the first is 9, and 9 squared is 81. And 27 to what power? Okay, we could figure out the fractional exponent, I guess, but we don't need to. So what we want to do is we want to break it down even further. Okay, we want to rewrite the 9 with a base of 3, and that would be 3 squared. And then we want to do the same with the 27. Okay, what common factor do they have that 9 and 27 have that we can break it down even further? And you know that 27 is 3 to the third power. So we're going to replace the 9 with 3 squared, and then we still have the 2x. And we're going to replace the 27 with 3 to the third, and then we still have the x minus 1 behind it. So now again, we have the same base. Now we can set them equal to each other. And solve. And we end up with x equals -3. And again, I could check that. I could plug that back in, and they should be equal to each other. All right, let's look at one that has fractions involved. So let's say we have 81 to the 3 minus x power equals 1/3 to the 5x minus 6. All right, well, we're going to have to change those bases. So 81 equals something, and 1/3 equals something. All right, well, again, we want to break it down into its basics. So 81 and 1/3. Okay, well, I think the base of 3 is going to be our best bet again. Okay, you need to know your factors. All right, well, 81 is equal to 3, I believe, to the 4th power, right? Okay, if you have to, double check it. 3 to the 4th power. It sure is. It is 81. Okay, now the 1/3, remember, you can rewrite that with a negative exponent. So if you recall, 1/3 can also be written as 3 to the -1 power, because the exponent on that is a 1. And remember, cross the line, change the sign. So we're going to replace the 81 with 3 to the 4 times 3 minus x. And we're going to replace the 1/3 with 3 to the -1 times 5x minus 6. All right, so now we can set them equal to each other. And solve. Here we go. And I believe we end up with x equals -6. Okay, hopefully I did the algebra correct on that one. And you could check it if you need to. All right, well, let's change it. So let's now look at how we can solve by taking a logarithm of each side. Okay, so if you forgot how the logarithms work, you need to go back and watch those other videos. All right, so let's say we have 2 to the x equals 5. Well, there's no way you're going to be able to convert just by looking at it, 2 to what power is 5? Okay, like, well, I know that 2 to the first is 2. I know that 2 to 2 squared is 4. I know that 2 to the third is 8. Okay, well, that means the answer to this is going to be somewhere between 2 squared and 2 to the third. So the answer is going to be a decimal, 2 point something. Well, how in the world are we going to find that? Okay, well, this is where the logarithms come into play. So remember, what you do on one side, you do to the other. So let's go ahead. So since this is a base of 2, I'm going to write this now as log base 2 to the x equals log base 2 5. Okay. Again, what I do to one side, I do to the other side. Now, if you remember your rules, this is going to cancel out. And so I'm left with x equals log base 2 5. Now remember, we have a change of base formula. And so what we can do now is we can take log of 5 and divide it by log of 2. And this is where the calculator is going to come in. All right, so change of base formula, we can go log of 5, close it after the 5, divided by log of 2. And yes, it is. It's a decimal between 2 and 3, and it's 2.3219, etc. Okay, we're going to round to the 100th place, so I'm going to round 2 decimal places. And when we round, we should probably use the wavy equal sign. So approximately 2.32. All right. Let's take a look at another one. Okay, this time let's go with 9 to the x power equals 35. All right, so I want to get rid of, I need to figure out x. So I want to get rid of the base of 9. Okay, so again, I'm going to take the log of both sides. But since that is a 9, now I'm going to do log base 9 to the x equals log base 9 35. Okay, these cancel out. So we're left with x equals log base 9 35. Use our change of base formula. Log of 35 divided by log of 9. All right, type that in. I'm not going to take the time to go to the calculator. Pause the video if you need to, practice it. Log of 35 divided by log of 9 is approximately 1.62. All right, now remember we can also use natural log to solve some things. All right, so let's take a look at this problem. So we've got 4. E to the negative 0.3x minus 7 equals 13. Okay, well, all of a sudden there's a whole bunch of stuff thrown at us. Okay, well, first of all, we need to get rid of everything around the base. Okay, and the base is this E right here. All right, so the first thing we're going to do is we're going to get rid of the minus 7. So just like solving a regular equation, we're going to add 7 to both sides. All right, so now we have 4e to the negative 0.3x equals 20. All right, now we're going to get rid of the 4, divide both sides by 4, and so now we have e to the negative 0.3x equals 5. Well, how do we get, what will cancel out the e? What do we need to do to both sides? All right, well, remember, if you're looking at your calculator, the ln and the e, the natural log, okay, they're inverses of each other, so they cancel each other out. So just like what we did on those other screens, we're going to take the natural log, let me make sure that's an n, the natural log e to the negative 0.3x equals the natural log of 5. Again, what you do on one side, you do to the other. All right, so what's the rule say? These cancel out, and we're left with negative 0.3x equals the natural log of 5. Now again, our goal is to get x by itself, so we're going to divide both sides by the negative 0.3. All right, we're going to use our calculator, so let me demonstrate that. So now we're going to go the natural log of 5. You want to close it, and then we're going to divide by negative 0.3. So our answer is approximately, oops, Our answer is approximately negative 5.37. Nope, 36. All right. All right, let's keep going here. Next, we're going to solve logarithmic equations. If log base bx equals log base bx, then x equals y. Okay, what in the world does that mean? Okay, so let's take a look. Here's an example. So let's say we have log base 4 to 2x plus 8 equals log base 4 6x minus 12. All right, well, folks, you will notice again that the bases are the same. When the bases are the same, we can simply take the 2x plus 8 and set it equal to the 6x minus 12. All right, solve for x. All right, I don't need to do the algebra on that, ladies and gentlemen. That's intermediate algebra. Solve for x. All right. Okay, let's move on. Okay, let's take a look at it. Oh, I want to show you this also. Let me go back here. So it's also true. Let's say we had the natural log of 7x minus 4 equals the natural log of 2x plus 11, sorry. So natural log, again, you can just take those and set them equal to each other and then solve for x. All right, so it also works for natural log. All right, let's keep going. Okay, another method is to exponentiate each side of an equation. Again, the most challenging thing here is that you are going to have to be able to recognize the type of equation it is. All right, so let's say this is what this equation looks like. We've got log base 7, 3x minus 2 equals 2. All right, well, it's kind of a similar process here. I want to get rid of log base 7, so I'm going to exponentiate each side. So what I'm going to do is I'm going to make what I see on both sides my exponent, okay, exponentiate. So I'm going to put 7 to the power of all of that, and the same thing on the other side, 7 to the power of that. So what's happening? Well, these cancel each other out, and I am left with 3x minus 2 equals 7 squared. Well, we know what 7 squared is. 7 squared is 49. All right, then we're going to solve for x. And I'm not going to do the algebra for that. You can do the algebra for that by yourself. All right, let's keep going here. All right, let's do one that's has a little bit more to it. So let's say we have log. Okay, let me fix that. Base 6, 3x plus log base 6, x minus 4 equals 2. All right, again, what do you notice? You notice that the bases are the same. Using your rules that you learned earlier, see this plus sign? Okay, that tells us that we can take these two things, and the rule is we're going to multiply. Okay, rules of logarithms. So we're going to rewrite this as 3x times x minus 4 equals 2. All right, now we're going to use what I just showed you in the last slide. We're going to exponentiate. Again, you have to get it down to a single log 6. You can't have two of these showing. You can only have one. So you have to use your exponent rules. Or not your exponent rules, your logarithm rules. All right, so what I'm going to do is I'm going to now make both sides an exponent. So I'm going to put base 6 and base 6. These cancel, and so what am I left with? 3x times x minus 4 equals 6 squared. All right, well, I'm going to go ahead and solve this one because I need to remind you of a few things. All right, so when we distribute this, we're going to end up with 3x squared minus 12x equals 36. Oh, it's quadratic. All right, well, you have two options. You can either factor or use the quadratic formula. All right, I'm going to see if I can factor it. Either way, I need to set it equal to 0. So I'm going to take away the 36 from both sides. All right,